Hi everyone, it's Haley. First, I want to apologize. I left my physical poster at work, so I'm going to just speak through this video to you all, and then I will share the PDF of my poster. So to kind of give a background about my internship, so I worked with Cambridge Technologies, which is a local vaccine company, but also the Sioux County Extension Office here in Northwest Iowa. And we kind of did a group project working together on potency testing of vaccines that are made specifically for either cattle or swine. Just for the sake of time, we focused more so on cattle. It would be really interesting to look at the differences, but hopefully in the future I have more time to do so. So, during the duration of my internship, I spent quite a bit of the time actually developing the test and then running the test and gathering all the data. And then the last third of my internship time, I spent actually putting all that data together, creating my poster that I'm presenting to you guys, as well as what I presented to other groups with the Extension Office. And then yeah, like I just said, the Extension Office and myself, we were able to present this to a meeting of theirs that's held quarterly for their local cattle producers, mostly because we focused on cattle, like I said. Unfortunately, our attendance was really low that day, so they have offered me to come back to do it again, which is great, and I look forward to doing. So, to kind of move into my poster, like I said, I focused on the potency testing of vaccines. Cambridge Technologies was the company that I worked with, and their main goal and objective is to create safe and effective vaccines for both cattle and swine. So that is why I worked with them. So, as producers of any sort of animal, I think it's important that we know that we have a quality vaccine that we're going to give to our herd, whether that is swine or cattle. Potency testing is one of these ways that we can look at the effectiveness of our vaccines. So, potency testing is done during the production, the development stages, and it measures the ability of a certain drug or medicine to exhibit a certain response at certain doses. So that seems very scientific, but in simpler terms, potency testing really just evaluates when and how effective your level of, say, effectiveness hits when that drug is given to an animal. And I'll explain more and try to make it much more simpler going forward. So the main objective of our study was to understand the relevance of this new potency testing. It's fairly new. I should back up and say there is potency assay testings that has been done for long periods of time for other things such as cells, gene mutations, etc. But there really hasn't been much done as far as measuring the efficiency of vaccines. So that was our main goal here. So the methodology, so we specifically use swine and bovine N1 and N2 antibodies. As I said, we spent more of our time doing this bovine. Recently there's been an increase in more products with these antibodies just because of the new diseases and illnesses that are going around. So we did this experiment through 3 basic steps. So first we had to do our research. We really had to understand how potency testing for other things was done, so we could kind of get a basis to start for our own. And then we also did comparison studies, so we looked at, again, the research that's already been done, we looked at studies that have already been done. And there was one similar study that the Extension Office found where someone else had tried to do, or had started to do, potency testing for a different animal. I believe it was poultry, maybe? I can't remember. We didn't spend much time looking at that one. But we really wanted to make sure we had a firm background understanding before we moved on and just created a new test in ourselves. And from there we went into our experiments. Obviously it was trial and error at first, so the first few, I will tell you, were not good. We didn't even get all the way through the test, and we were like, scrap that. It's not going to be effective, we can already tell. No time in wasting time and resources on that. So moving forward, once we finally got the test, solidified in the steps, and we got through a full test once, and we did produce results, they might not have been the right results or the results we were really wanting, but we did finally get through a test, and so we stuck to that. And I will tell you that takes a lot of patience and a lot of hard work and determination, because there were several days where we were tired of it, because you have to run this, repeatedly, several days. And so being understanding and open to doing the same thing every day, it's just something we had to get used to. So once we did finalize the steps of our test, we took those antibodies, N1 and N2, and they were tested once every day for 3 weeks so we could get accurate results. And I will say we did not always get accurate results. There were days where our results were way too high. There were days when our results were the opposite and way too low. And there were days when our results were just incomprehensive. We don't know what happened, but we obviously, just due to the duration of my time doing this project, we didn't have a bunch of time in the world to continue doing it to further understand all the things that went wrong. In the end, if we had more time, that is something we would definitely look into, because it was, it's a very interesting test that we've come up with, and we really think that with more time, it will become even more effective. So basically the test is a 8-hour test. It's an all-day test. You start at 8 a.m. and then you are done by 4 p.m. Just for one set of samples. So I'll save all the scientific steps for you guys. I don't want to bore you too much, but basically you put the antibodies in the plate, you wash them a few times, well, more than a few, quite a handful of times. You add into it your antigens, your reactors, your reagents, and then at the end you put your plate, your final plate with what is needed in it, into a reader that's connected, an ELISA reader that is connected to the computer. And the computer comes up with and shows you the results, which I'll show you a graph that's similar on my poster here in a second, to what your results would be. And based off our testing, the results that we had, N2 antibody typically tested higher than our reference sample. And when I say reference sample, I'm just talking about the control sample. And then our N1 tested slightly lower than the reference sample. And that wasn't always the case, because like I said, the first couple weeks we had results that were all over the place. So that's speaking once we got through that and we got to more of the stable point of our testing, where everything started to end up looking more similar. So from there, on section 5 on my poster, you'll see the analysis section, and there's that graph I was referencing. So the purple solid line is your reference or control. So every experiment that you do, you always have a control group. That is your reference. That is just a standard curve that's been designated or designed by the computer analysis system based on the range that you have given the computer. And then as you can see on the chart, there are several different colored dotted lines, and those are just showing you like sub X is sample A, sub Y is sample B, sub Z is sample C. So for us, sub X could be N1 and sub Y could be N2, or vice versa. So like I said, we want it to be close to that purple line, because that means that we are hitting that, happy medium as to where the amount of dose that is given is a solid response time as far as how effective the antibodies are when you administer that vaccine. So like I said, N2 was testing higher, meaning it looks more like sub Y line, or the blue line there, where the response time was happening sooner. And N1 was looking more like sub X, the yellow line, where it was happening later because there was a bigger dose given. Now, if you move over to conclusions, based off of what we have gathered from producers and just general knowledge, N2 typically had the faster or sooner response time. So most people would say that they'd rather like that. They'd rather want the N2 antibody in the vaccine, just because, okay, say their herd has a illness spreading, the sooner the response time, the sooner they get through that, and the sooner they recover and start growing and gaining as they're expected. But again, this is all based upon personal preference or situation, so that's not always the case. So that's not to say that the N1 antibody still wasn't effective. Regardless of preference of N1 or N2 antibodies, our findings showed that regardless of the antibodies, potency testing is going to become quite essential, I think, going forward when creating vaccines, and I think will help us to continue to grow our herds even more. When we have healthy herds and fast-growing herds that don't have these health issues, then we truly produce at our best rate. So that's kind of the basis of what I spent my semester doing. It was quite interesting. Like I said, lots of patience, lots of trial and error throughout the semester, I would say. But overall, I think potency testing has a bright future. It was a fun project. It was great to work with Sioux County Extension. And if you guys have any questions, you can reach out to me directly. Again, I apologize that I don't have my actual physical poster here with me. Another thing I want to note on my poster is down in the middle bottom section, there is a relative study about potency testing that they did with cells and genetics. If you're interested in looking into that further, go ahead. But like I said, if you have any questions, feel free to reach out. I hope you all had a great semester as well.